Welcome to Earth Plus Humans, where we explore a problem in need of solutions.
I'm Trislan Nelson, Director and Professor at the School of Geographical Sciences and Urban Planning at Arizona State University. Today on Earth Plus Humans, we're talking about climate extremes. To help me introduce the topic, I've invited Finn and Beatrice Nelson Walker. Finn is 11, and he's into soccer, Lego, and video games. Beatrice is turning 8 today and loves cats, crafting, and biking. And yes, they're my kids and huge fans of the podcast Earth Plus Humans.
We are?
Yes, you are. Okay, Beatrice, since it's your birthday, the first question is for you. What is climate change?
Climate change is something that makes the world worse. It's like pollution and killing more animals.
Finn, can you tell me why are kids worried about climate change these days?
Because they know that when they get older, that they're the ones who are going to have to take care of it, and they don't want to have to clean up other people's messes.
What kind of messes in particular are you worried about?
I'm worried that the air quality is going to go down.
Beatrice, can you tell me what things you worry about when you think of a future with climate change?
Well, I think that there's going to be a lot more of litter. The air quality is going to be unhealthy. It's not going to be nice anymore. There's not going to be as much plants, not as much animals. Us humans could suffer more.
I think that's a good point. I think there's going to be more suffering if we don't take care of the planet. So, what are some things you think we should be doing to reduce climate change?
We should be reusing materials because not everything that's recycled actually is reused, because most of it just goes and gets shipped off to some place where they fill it in a landfill.
Beatrice, what do you think we should be doing to reduce climate change?
Well, I definitely go with Finn. We need to reuse more. We need to find a way to make less trash. We need to clean up after ourselves. We need to pick up the trash.
Thanks for the great advice, kids. Now, listeners, before you head out to do your part for climate change, let's hear from Dr. Randy Cerveny, an expert in climate extremes. And stay tuned at the end of our episode for some special outtakes. They highlight how hard our producer Megan Martin worked to bring you this episode, and I promise you'll laugh. Joining me on Earth Plus Humans to talk about climate extremes is Dr. Randy Cerveny. Randy is a very busy professor in the School of Geographical Sciences and Urban Planning. He directs our meteorology program, is frequently featured in mainstream media outlets, and has written popular books including Freaks of the Storm and Weather's Greatest Mysteries Solved. But today we're going to lean on Randy's work with the United Nations and World Meteorological Organization, verifying global weather records and climate extremes. Welcome, Randy.
Hey, thanks for having me.
So, can you tell me what is the World Meteorological Organization that records these climate extreme records?
Well, it all started back in around 2006, and I was talking with some fellow scientists. We realized that there really wasn't any one place that listed where the hottest place in the world was, or where the coldest place, or where the windiest place was. Individual countries had that, but we didn't have anything for the world. And so we wrote up a professional article on that, and it made a little bit of notice. And the United Nations, in particular, the group that's called the World Meteorological Organization, which is kind of the United Nations of all weather services, got in touch with me and said, "We'll do it as long as you're willing to take charge."
We'll do it as long as you do all the work.
Basically.
So you're basically the Guinness Book of World Records for climate.
Right. And in fact, now, believe it or not, the Guinness Book of World Records actually contacts us. And so I am a consultant with the Guinness Book. When they put out a new records book on anything involving weather, they contact us first, which is kind of nice.
So when you do these investigations, tell me what is involved with verifying one of these climate records.
Well, when I first started this project back in 2006, I thought it was going to be a pretty straightforward thing. It's gotten to be kind of complicated now. What we do is when there's a possibility of a new record, we first do a quick preliminary investigation, say, is this legitimate or is this some crackpot that's contacting us? And then if it's legitimate, we will put together a committee of international scientists from around the world that investigate this particular extreme.
In part, I've wondered, with the climate changing, one of the things we're expecting with climate change is more extreme weather. So how is this impacting your workload?
Well, what we're trying to do with this project, and it is one of the important things involving climate change, is we need to establish baselines. In order to know that climate's changing, we got to know what are the extremes right now. And then we can see, are we getting more of those over time? So one of our fundamental missions is to basically set the baseline for all extremes. And we thought when we set up the project that we might be doing a new investigation maybe once every couple of years or so. No, I've got right now 3 ongoing investigations going, and there will probably be more in the near future. It's one of those things that we are having neater stuff to look at, but we're also exceeding records in things like temperature.
Are you able to talk about the ongoing investigations?
Only in very general terms. We're looking at one involving lightning. We're looking at some temperatures in Greenland right now that are going to set some records. And we have just published, actually, a really cool study where we were verifying the 3rd hottest temperature ever recorded on the planet. And it took place not simultaneously, but in 2 separate locations, one in Kuwait and one in Pakistan.
Oh, wow. So what is the hottest location ever recorded? Where is it and what's the temperature?
The hottest location is Death Valley in California, and that temperature is 134 degrees. It happened all the way actually back in 1913, but that is the record. Now, it's a controversial record, but it is the one that we accept as being the hottest record ever recorded.
So did Death Valley call up and send you a T-shirt, or are people pretty happy when they make these climate extremes? Well,
it's surprising. I didn't expect this, but yes, there are places that take great pride in being an extreme. It used to be that the windiest place in the world was a reading that was taken in Mount Washington Observatory in New Hampshire. And a few years ago, one of my committees was actually investigating. We found an automated weather station down in Australia during a hurricane had a gust that was substantially stronger than that. And so we had to take that away from New Hampshire. And they were actually quite upset. I had a reporter from New Hampshire tell me that my passport to New Hampshire has been revoked. I can no longer go to New Hampshire because they no longer have that record. So.
Right. So one thing I wonder is sometimes you hear people say or post on their social media, today is so hot. Obviously, climate change is happening. This is an unseasonable temperature. This is more evidence of climate change. And I always wonder when people make these observations about an individual day, well, is this climate change or is this just unseasonable weather?
That's an important distinction, is that people tend to mix up weather and climate. Just a few weeks ago, we had a situation where we already were having snow up in the northwest part of the country. And there were immediately posts on social media that, well, there's this global warming and we can't have a blizzard when temperatures are going. Weather is day-to-day changes. Climate is long-term variations. So if we see year after year of increasingly warmer temperatures, that's climate change. Any one particular day could be just natural variability, or it could be part of that trend. But the key when we're looking at climate is to look at the long term. We're not looking at just one day. We're looking at that one day in comparison with the last decade, the last century. And what we have found is pretty dramatically over the last 100 years, temperatures across the planet have actually risen pretty dramatically.
Earth Plus Humans is brought to you by the School of Geographical Sciences and Urban Planning at Arizona State University. At our school, we are working to advance geospatial knowledge for a complex world, emphasizing education, research, and applied solutions to urban and environmental problems. You can learn more about our school by visiting us online at sgsup.asu.edu. Now back to the show. I'm a Canadian, so obviously I love to talk about the weather, but I don't think I'm alone. I think people are affected each day by weather, and so, we talk about it a lot. It's on our radar. And so sometimes I'm surprised that given this, it's taken so long for people to feel a personal responsibility for climate change. And I think with what we're seeing with Greta and youth, we're certainly seeing more interest in, as an individual, what's my responsibility? So what should people be thinking about, or what can they be doing to respond to climate change?
Well, one of the biggest things, of course, is that we got to work as a team, that while individuals can make a difference to their locale, one of the things that we notice, for example, is that Phoenix is about 5 to 7 degrees warmer than the surrounding deserts. And part of that is because of the city. Well, we can make changes in terms of planting trees, in terms of landscaping, in terms of all the different kinds of things that we can do to cool our particular locale down. But then if we can start working as a bigger unit in terms of the state or in terms of the country, we can start to have an even bigger effect. One of the big problems with climate change, and as a scientist, I've always found this kind of odd, because when I started the field many, many years ago, I did it because I loved science and I liked doing stuff. And I didn't think doing stuff involving weather. And I didn't think of this as being political. And it's one of the weird things that's happened in recent years is that science, in particular climate science, has become political. And I think we have to overcome that. We have to look at the broader picture and say, what are the scientists telling us, and what does that mean for our individual lifestyles and for our children and our grandchildren?
As meteorologists, I think that this is a really interesting role that sort of connects physical science to public outreach. So it's often a communication that happens, I think, in this role. So what is the role of meteorologists in educating the public about climate change and impacting policy?
Well, that's an interesting issue, and it's one that's being discussed in our groups associated with meteorology and climate. One of the primary groups that has a day-to-day impact with the general public are broadcast meteorologists. And we have some of the best here in the Valley that are trying to make people more aware of not only the day-to-day variations in weather, but the long-term variations in climate as well. Amber Sullins in Channel 15 is one of the best in terms of having segments that are taking what's happening when we set a record high in Phoenix, for example, and what does that mean when we look at the last 20 or 30 years? Well, she says, and it's easily proven, that we are having many, many more record high temperatures in places like Phoenix than we did just 20 or 30 years ago. We have not set a record low temperature here in Phoenix for the last 30 years. Wow. That's kind of surprising.
And what's happening with evening temperatures in Phoenix? Because I hear this talked about as an area of concern.
Yeah, actually, in terms of climate change, the biggest impact isn't the daily high temperature, it's the daily low temperature. One of the things that we have noticed in recent years is that our low temperatures are creeping up faster than our high temperatures. So I have made a prediction. I made this prediction about 12 years ago, and unfortunately, it's going to come true. I hope not, but it's going to come true, that someday here in Phoenix, we will have a record low temperature where the temperature doesn't get below 100 degrees.
Oh, gosh.
Right now, our record highest low temperature is 96.
Wow. Are these low temperatures creeping up because the climate's changing, or is it because of how we're structuring our cities on the ground?
Both, actually. What we find is that the asphalt and the concrete that is associated with our city absorbs the daily heat and then emits it at night. So that puts in an extra source of heat. But, and a lot of people don't realize this, also cities are big areas where we have enhanced greenhouse effects. That greenhouse is where the carbon dioxide in our atmosphere holds on to the heat of the earth as well and keeps the place hotter. Well, cities have about 600 parts per million carbon dioxide. The surrounding deserts only have about 400. So we here in a city have already experiencing what the planet's going to see in probably the next 10 to 15 years.
Oh, so how can green infrastructure or more resilient infrastructure or changing how we can build our cities impact?
Well, that's actually a very cool thing that is currently being done. And some of the best work is being done right here in ASU and in our own particular school.
Sun Devils.
Exactly. When you have people like David Saylor and David Hondula and Matt Georgescu, they're looking at exactly how cities can be modified and changed in order to limit how much heat is going to go out into the atmosphere and then cause a more regional or even global problem. So the nice thing is that ASU, and particularly our particular school, is on the forefront of this kind of research.
How do meteorologists have confidence that the long-term trends we're seeing, say over 30 years, which really in the scheme of things isn't that long, how do we know that it's climate change and not just some kind of cycle that we're in?
Well, one of the things that people get mixed up on is that there are lots of things that are operating on our climate. Our climate is not controlled by any one thing, whether it's greenhouse warming or the shape of the Earth's orbit or different factors that can change climate. They are all working at the same time. What is different about them is that they work at different time scales. So when I can look at climate change that involves year-to-year variations. If I blow up a volcano, that's going to have an immediate impact on our climate for the next 3 to 4 years afterwards. If I dump a whole bunch of carbon dioxide in the atmosphere, that's going to have an effect over the climate over the next few decades. If I change the Earth's orbit, that's going to have an effect on the climate over thousands of years. So the critical thing that we have to look at, and this is one of the problems when I hear people saying, oh, well, climate always is changing. Well, it is always changing, but the scale that we're working at has changed. That the kind of changes that we are seeing that have happened within the last, 50 years or so are unprecedented for what we have seen in the last 2 million years. So the things that are happening now, we don't have any background to be able to say, why did this happen? Because the things that are happening now haven't ever been seen before.
And so what kind of climate records do we use to look at things back 2 million years ago?
That's what's kind of cool, too. It's an aspect of climate that I call basically playing climate detective. It's unfortunately, we don't have cavemen looking at thermometers back then or measuring the rainfall. So we've got to come up with other ways to do that. A gooey way of doing it, there's something that are called pack rat middens. They're the nests that pack rats make in caves that are basically filled with their poop. And when they poop, they are pooping out the pollen that they have been eating from the plants that they eat. So by digging back through pack rat middens, we can actually determine what they were eating back thousands of years. And from what they were eating, certain plants only grow under certain kind of conditions, so we can figure out what the weather was like during those times when those plants were growing. Some of the ways that we have of doing that are looking at tree rings. It was a science that actually started here in Arizona 100 years ago. No other place had it until we did it about 100 years ago. And that's one of the really cool things that can tell us lots about what climate was like upwards of 5 to 1,000, maybe 1,500 years ago. If we want to go back further in time, you can go down to places like Antarctica. I was down there and we dug into the ice and pulled out ice cores, and that can tell us back to maybe 2 million years or so. If we dig into the bottom of oceans can tell us things about the climate maybe all the way back to the age of the dinosaurs. So all these different things can tell us what has happened to climate in long terms in the past.
I'm so glad you brought up tree rings because my very first research project I ever did as an undergraduate student was with tree rings. And that's really was one of the pathways to geography for me.
Oh, and tree rings are just incredibly cool. There's so much that you can do with them, particularly out here in the Southwest. They're one of the primary ways, since the Anasazi, for example, didn't leave written records of temperature and such. We need to know what happened to them. And looking at tree rings is one really cool way to say, all right, this is what happened 1,000 years ago here in this area.
As someone who thinks about climate and weather every day, what is your hope for the future, or what are you worried about when you think about the climate in 50 or 100 years?
Well, I tend not to go into the catastrophic frame of thinking. I mean, when I'm talking to school kids, for example, the planet is still going to be around in 50 to 100 years. It may be a markedly different kind of planet than what we have today if we don't do anything. But what we have to realize is that we are stuck on this planet, and therefore it is our only place to be right now. We have to make the changes that are going to allow us and our kids and our grandkids to be able to live on this planet into the future. And those kind of decisions are stuff that I have hopes about. I also am looking at political situations and I wonder, but I do have hope.
If you had a magic wand and could make us as a society make one major change with the climate in mind, what would it be? Probably the use of automobiles. If we could cut back on automobiles, particularly in urban areas where we have alternatives that are easily used or could be easily used, that would probably make the biggest long-term difference if we were able to do that on a global scale. That is music to my ears. Okay, last question for you. If you could go anywhere in the world to explore or experience extreme weather, where would you go?
Probably the place that's on my bucket list to go to is India. The monsoon rains that they have in India are record-breaking. And in fact, some of the highest rainfall rates in the world are measured in India. And so I think it would be really cool to go to a place like Cherrapunji and see water not measured in inches, but measured in yards of water.
Wow, yes. Well, thank you so much for joining us today. This has been really fun, and we will continue to look for you in a variety of outlets to learn more about weather.
Oh, yeah, thanks.
Thank you for joining us for this episode of Earth Plus Humans, produced by the School of Geographical Sciences and Urban Planning at Arizona State University. You can learn more about our school by visiting sgsup.asu.edu. Music for this podcast is brought to you by Zachary Wiggins and Samuel Pena. This episode was executive produced by Megan Martin. Now get out there and be part of this solution.
Bee, stop wrestling around.
Finn, focus here. I love you.
Poop. Grown-ups, you've been very irresponsible. I hope you realize that. Wait, are there trademarks on this thing?
No.
Oh, so... What? I smell like soup.
Salty soup. Oh, I can't wait until my friends hear that.
Now we do have an outtake throughout for sure. We're not putting that part on the podcast. All right, you two.
I know the floor.
Is it still recording?
It is.
Oh. What's so funny?
So funny.
You're broken.